In this video, I will talk a little bit about what it means for a system to be causal and what it means for a system to be non-causal. Suppose we have a system with input x of n, and let's say the output of this system is y of n. Now we say that the system is non-causal or anticipative if the output from the system at any time depends on any of the future values of the input. So what I mean by that is, if you look at the output of the system at any given time n naught, if this depends on the input at some time which is larger than n naught, so if it depends on any of the values of x of k for k greater than n naught, then we say that the system is non-causal. Now, it's important to realize that this system's output at any time n naught, if it starts to depend on a future value of the input, then we say that the system is non-causal. So in other words, it may happen that for some values of n naught, the output of the system only depends on the present and past values of the input. But even if there is one value of n naught for which the output of the system depends on a future value of the input, then we say that the system is non-causal. And the opposite of this is a causal system. That is, in a causal system, the output at any given time depends only on the present and past values. Okay. Now, most of the books will start by defining the system as being causal if the output at any given time depends only on the present and past values. Now, I have seen a few students get confused by thinking that the output has to depend on the present and past values for a system to be non-causal, to be causal. And now that's not what it means. That's why I prefer to define a non-causal system as something for which the value, output at any given time depends on a future value. Okay. Now, what I mean by that is, if there is a system for which the output depends only on the present value of the input, the system is still causal. It does not have to depend on the present and past values. All it means is it does not depend on any future value. That's all that means. Okay. I'll give you a couple of examples just to see what's a causal system and what's non-causal. Now, if you look at system 1, the output of the system y of n is given by an average of the values taken by the input at time n minus 1, and time n minus 2. So clearly, the output of the system at any given time n depends only on the present value, the immediate past, and 2 time instants before. So this system is clearly causal. By contrast, if you look at system 2, the output of the system at time n depends not only on the input at the present time, the input at the present time and the input 1 time instant before, but it also depends on a future value of the input. In other words, y of n depends on x of n plus 1. So this system is what we say is non-causal. Okay. Now, it may seem a little bizarre as to how the output of a system at a particular time can actually depend on a future value of the input. And in fact, this is a little bit confusing. So I have made a companion video to this where I will talk about this in a little more detail. In this video, I just want to stick to a formal definition of causality and give you a few examples of how to test if a system is causal or non-causal. And I would strongly urge you to watch the other video, which goes through a little more of an elaborate explanation of this. So we'll just work out a couple of examples. It's just a fairly simple idea. So let's work out a couple of examples. So suppose I have the system whose output y of n is given by x of negative n. Now, is this system causal or not? Like always, I think you may want to stop the video at this point and think for yourself whether the system is causal or not. Okay. Now, the answer to this question is that the system is not causal, because you can see when n takes negative values, so for example, if you look at y of negative 1, this tells me that y of negative 1 is x of 1. So clearly y of negative 1 depends on a future value of the input, and hence the system is not causal. I mean, this is also a good example of something that I talked just a few minutes back. You know, if you had plugged in any positive value of n, so if you had looked at y of 1, this depends only on a past value of the input, right? Y of 1 is x of negative 1. But that alone is not enough to conclude that the system is causal. Because if you look at some negative values of n, clearly it depends on a future value. Let me quickly work out another example. And this is to tell you to avoid some common mistakes. Suppose I have a continuous time system y of t. Actually, before I talk about the continuous time system, now the definition of causality for a continuous time system is pretty much exactly what it is for a discrete time system. Okay, so let's look at a continuous time system given by y of t is sine of t plus 1 times x of t. Now, is this system causal or not? Well, the thing to note here is not to get confused by this t plus 1 here. Now, the sine t plus 1 is just a parameter in this system. So what's the system doing? The output of the system y of t at any given time is the input at that time, namely x of t, times something that depends on time. You know, this is a sine t plus 1. But y of t does not depend on any of the input values from the future. Now, that's what's important to decide whether a system is causal or not. Okay, so just because we have a t plus 1 here, it does not mean that the system is not causal. So this system is causal because the output at any given time t depends only on the input at that particular time t. It does not depend on the input at any future values of time. So this system is indeed causal. Okay. Now, like I said a little bit before in the video, if you are wondering about why we want to look at non-causal systems, it's kind of confusing as to why would you want to think of a system where the output at a particular time depends on a future value of the input, right? These systems are not even physically realizable, because in any physically realizable system, it doesn't make sense for the output to be dependent on a future value of the input. Then why do we really even care about these systems? So for that, I would suggest you watch the next video, which gives a little bit of an explanation about causal and non-causal systems.